Okay, we're doing a tutorial on how to mill the Fab ISP. The first thing is we're using Ubuntu so that we have the proper Fab modules for the MDX40A. The first thing we're going to do is open the terminal, which is here, and we get to see the terminal. We're going to type in Fab for the Fab modules, and it's going to give us this, which we are going to use. We'll go from right here, PNG, to RML, and then click hit make PNG RML. We're going to load our PNG, which is on our desktop, the Fab ISP 44. Open. Okay, so here it is. And we're gonna leave all of our presets here the same. We're gonna go up to the top here, and we're gonna choose the end mill that we're using, which is the 1/64. It's gonna give us a new set of presets down here that are already predetermined: 3D plane, how far it needs to go down, etc. We're gonna hit make path. It calculates for us, and we got our path here. And then what we're gonna do is step over to the machine. The machine that we're using, the Mandela MDX40, and what we're gonna do is make sure it's on, make sure the USB is connected to the computer, and then we're gonna put in our 1/64 inch end mill and prep our PCB board that we're gonna put in there. Alright, so we have our 1/64 inch end mill, which is very delicate, so we want to pay close attention to how we treat it. It should have this cap on it when it comes out of here, and it should be put back in here when we put it away. So now I'm going to load it in the machine. We open it up, take the blue cap off, and this machine we have to use 2 wrenches to tighten. I'm going to put it all the way up, and then when I come back to zero it later, that's when we'll adjust to exactly where it should be on the board. So we put it in, hand tighten, close this. The machine will not move unless this is closed. And then we're going to come back over to prepare our board. We're going to use a piece of scrap board that's large enough, that's one-sided for this purpose. So I'm going to find one that doesn't have any marks on it and is big enough for what I'm doing. So this piece should be perfect. So to prepare the board, what we're going to do is use the double-sided tape and make sure that we go across the entire back of the board without overlapping tape, because what we are attempting to do is get the board as flat as possible on the sacrificial layer. So an overlap in tape would cause that to not be the case. So I'm just going to put four strips of tape across the back of my board, and get them as close together as possible with no bumps. That's flat across the back of it. And now I'm going to put this onto the sacrificial layer, which is inside the machine already. I'm going to hit view to bring it forward. I'm going to dust off just to make sure there's no dust on this board since we're reusing it. And I'm going to place this so that it's in the corner of the sacrificial layer, and making sure that it's pressed down all the way around. And then I'm going to close the machine. And so now I'm going to zero the end mill, which is right here, to make sure that it's just touching the top of this surface. So I need to go back over to the computer so that I can lower it down and make sure it's in the right position. So now what we're going to do is zero the end mill tip, meaning place it right just so that it's touching the board exactly how we want it to. So I'm going to move the position of the end mill on top of a space that would be good for us to zero the tip at. So I'm going to click move to XY min, and then click it, and then the machine will move. And for our purpose, we want it at the back of the board because there's a slight slope, so that's a good spot. So now what I'm going to do is loosen this. This is still a little tricky for me because we have to use both wrenches as well as hold the end mill. So organizing myself and holding the end mill as I loosen it, drop it down, give it a tap just so that there's nothing there and that I know that it's touching. Hold it in position while we tighten, and just hand tighten. Now we're ready to send. So I actually want this to start closer in the corner, so I'm going to change the XY min. The only reason that I changed it was to account for the slope in the board, so I wanted to test it at the back of the board. The speed is at a default. We can go up to 8, but we'll just go up a little bit so it can be a little bit quicker. We will then click Make RML, which is right here, and it calculates how much time it'll take to make it. We will move to XY min so that it's starting in the position that we want it to, and then we will click Send It, and that will tell the machine to start milling. noticing all the dust. That's a good thing. That means that our end mill is good and it's cutting through the copper layer.
I would zero it again, either on the side here, because it really didn't get much of these traces.
Okay.
Yeah, try that. Excuse me. Zero it over here on this side.
And make sure it's tight enough.
Yeah, and
so
make sure it's tight
move.
so that it's not moving up or down.
Okay.
As you know, after you secure it.
Okay. Thank you. So what happened was, as you can see, it didn't come out all the way. What we're going to do is zero it at the point where the least traces came out, as well as make sure that the end mill is nice and tight so it doesn't move up and down while it's doing the job. Actually, after cleaning it off, it appears to be pretty good. I can probably test it to make sure that none of these traces are broken, but we can probably go with this. So I may be cutting it out in a moment. Okay, we're cleaning it up a little bit, and here is our milled Fab ISP 44 board. Let's go stuff it. Okay, now we're in the electronics lab. I'm pulling out my components. I got my board set up. I'm going to switch on the soldering iron. And one thing important that I've learned is to discharge any static electricity by putting one hand on a mat and then something else that's on the ground. And then for the very delicate, well, we'll say high-powered AT tiny microchip, we're going to go straight from the bag onto the mat so as to not expose it to any static. And now we're going to get ready to stuff the board. Okay, one trick that I learned with the solder is to make a pad for where we're going to put our first piece, as well as to start from the middle of the board and as low on the board, basically going from low to high and going from inside out. So I'm gonna just start by putting a little bit of solder on these pads. Warm the pad up. Okay. And what I'm gonna also do is test as I go. So that we know each piece. Great. Great. I'm going to do that for each piece because this will be my third time making this board. And I really want to make sure that all the connections are good before completing the whole thing. So I'm going to do a few more. Seems tedious, but I want to make sure all the connections are good. So working Okay, so I've got all of the smaller pieces on the board. Now I'm going to attach the AT Tiny 44 and then the pin header and then the USB, and then we're going to program it. Alright, so we've got our board together. We've connected the mini USB to our computer, and we've got our AVR programmer. We're going to make sure that the red one, the signifying pin 1, goes on the right place, which is this pin, the inner one, which we know from the schematic. And when we plug it in, we should have 2 green lights. So let's see what happens. Awesome, it works. Okay, so now we can begin programming our board, which I'm just going to follow the directions on the Fab Academy website.